In this video, we're going to simplify the expression as shown on the screen. It's a problem from Putnam 1995. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. This problem involves an infinite continued fraction. The key to solve problems related to this is to write part of the expression, claim this to be equal to the entire infinite continued fraction. But this can only work if we remove the 8th root. So what I'm going to do is to, let's say, x equal to this entire expression. And I'm going to bring both sides to its 8th power, which means x to the power of 8 is going to equal to that infinite continued fraction. So let me remove the radical sign. Now at this point, the blue box, I can say that is also equal to x to the power of 8. So now from this, we can say that, therefore, x to the power of 8 is equal to 2207 minus 1 over x to the power of 8. And so x to the power of 8 plus 1 plus its reciprocal is equal to 2207. Now here comes the second trick. We have used the first one, which is to claim that part of the infinite continued fraction is actually equal to the entire expression. Now the second trick is that I'm going to add 2 on both sides. This is because if I add 2 on x to the power of 8 plus its reciprocal, the expression highlighted in yellow, is going to equal to x to the power of 4 plus its reciprocal all squared. And at the same time, the right hand side is equal to 2209, which is at the same time a perfect squared. So I'm going to simplify that and say that x to the 4 plus its reciprocal is equal to either 47 or minus 47. But we know that because we are at power 4, so left hand side must be positive, at least non-negative. Well, it's actually positive because we have x as the denominator and we know that it's non-zero, so we cannot have 0 at left hand side. So anyway, it just cannot be minus 47, so let's reject that part. So that means x to the power 4 plus its reciprocal equals 47. Now actually we can iterate this trick by doing again and again. I'm going to add 2 on both sides. And this is actually where the magic of this problem lies, because whenever I keep doing that, I still get a perfect square. This is why the number 2207 is chosen. So it's actually 49. And so that means x squared plus 1 over x squared is equal to either 7 or minus 7. Using a similar argument, I can reject minus 7. So we know that x squared plus its reciprocal is equal to 7. Now from this, I can again add 2 on both sides. So to solve for x, now I have right hand side to be equal to 3 squared. So that means it's either 3 or minus 3. Now of course again x is positive, so that means x plus 1 over x is again positive. So I reject the minus 3, and that means x plus 1 over x equals to 3. Now at this point, I'm going to just treat it like an ordinary quadratic equation by multiplying both sides by x. And I'm going to use the quadratic formula, which says that x is equal to 3 plus or minus square root of 3 squared minus 4 over 2. So x is either 3 plus square root of 5 over 2 or 3 minus square root of 5 over 2. So there are only two candidates left, and let's see which is the correct answer. So by approximating, we know that this is about 2.6 and something, while the smaller one is actually around 0.4, I guess, because root 5 is about 2.23, somewhere around that. But however, if we look at this expression, 2207 minus a fraction, and this fraction is also positive, but the numerator is 1, while the denominator is apparently larger than 1. So that means altogether, this whole bunch of numbers, this entire expression, should be about 2206 point something. And so if I take the 8th root of it, it would definitely not be something like 0.4, because 0.4 to the power of 8 should be another number that is smaller than 1, but this number is larger than 1, so it should only go to the larger number, which is 3 plus square root of 5 over 2. So that means this is the final answer.